For many people, statistics means lots of numbers and complex equations that are relegated to maths textbooks and standardized tests. But statistics permeates more into our lives than most people give it credit. Graduate study at the University of Oxford is an example of that. I wanted to find out more, so I asked.
My name is Max. I'm doing my DPhil or PhD in statistics. I've got quite an applied research project. My work is looking at earthquake impact modelling. So if an earthquake occurs, how can you then immediately predict the humanitarian impact, such as the number of fatalities, the number of people displaced? And so basically our model is trained using past events, and we fit the model by combining information on the hazard intensity with vulnerability covariates such as the Human Development Index, the gross national income, the population density, the soil stiffness, all those kinds of things that you think might affect the vulnerability of a region. And we combine that in the model with the real-time hazard intensity data to then make those predictions of the humanitarian impact, with the idea that then we can use that to guide the response and relief efforts.
When doing statistics, it's pretty clear how the data you have is really important. What's also important, though, is how that data is collected.
I feel like my research has the potential to really change the way that we collect data. My name is Desi. I am a third-year graduate student at the Department of Statistics. So oftentimes when we do machine learning, when we do statistical analysis, you assume the data is given, right? And oftentimes that might be the case. So sometimes you might not be able to control the data that you receive. But in many situations, that is actually not the case.
For example, if you're surveying people, as the author of the survey, you can choose the questions that are asked.
Using principled approaches to sort of design your surveys more appropriately, and getting a data set that is of much higher quality will lead to much better results when you do the statistical analysis, and ultimately it will lead to better decision making.
But once we have this data, it's important to accurately determine what it's telling us.
So my name is Victor Viker. I am a PhD student in statistics researching causality and understanding sort of within real-world experiments or within observed data that's been collected, what assumptions we need to make and then what calculations we can make to try and argue that something within that data set has actually caused something else. And as you can imagine, this is a question that has sort of both philosophical and statistical components in terms of how we look at it and how we think about it. But that's, of course, sort of an area of research that can be applied to a lot of different fields of study. You can look at economics or social sciences. One of the most common applications, and what a lot of our research pertains to, is clinical trials, and looking at sort of the development of new medicines. And when we're investigating a new drug or a new vaccine, can we say, does it work, and how well? Yeah.
Who are you? Hi, I'm Ruth McCabe. I'm a doctoral student working in statistical epidemiology here in the department. So my research is all about understanding the spread and impact of epidemics. So I work on basically what data sources do we have and how can they be used to help us understand the threat posed by infectious diseases. I also have a stream of research where I work on how modelling and analyses are used to inform policy, and particularly looking at that in the era of the COVID-19 pandemic. So I think the impact of my research is hopefully quite clear. We've all just lived through 3+ years of the COVID-19 pandemic, and we saw the huge toll that took on our daily lives. So the research that we do here, and in particular what I do in my PhD, is about better understanding these threats and then understanding the ways that we can mitigate them. And this is really important because the World Health Organization frequently says the next pandemic is a case of when, not if.